Software Engineering Radio, episode 133, Continuous Integration with Chris Reed.
This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 10 days. Thanks to our audience and the partners listed on our website for support. Welcome, listeners, to a new episode of Software Engineering Radio, recorded at JAU 2008. So this time we're going to talk about a topic that has been requested a couple of times. Sometimes people accuse us of discussing all kinds of advanced fancy stuff, but not looking at the basic hands-on stuff people need to know to actually run projects. And one of those topics that we didn't cover yet that falls in that category is continuous integration. And today we're going to talk about that with Chris Reed from ThoughtWorks. Hi, Chris.
Hey, how you doing?
I'm fine. I'm tired, as we just discussed.
Yeah.
But it doesn't matter. I just have to ask questions. So
Excellent. I'm doing all the hard work here.
Yeah. So, Chris, please introduce yourself to our listeners.
Yeah, so my name's Chris Reed. I work for ThoughtWorks. I've been at ThoughtWorks now for almost 4 years. There's an infrastructure specialist. So what I do is, my background is mostly system administration. I've been a developer. I was a developer for a couple of years. But then found that hardware and infrastructure and networks and all that kind of stuff was what really interested me more.
Mm-hmm.
But now I work for ThoughtWorks. I work kind of helping developers interact with the sysadmin teams at the clients. And part of that is actually hinges all around continuous integration, getting continuous integration up and working at the clients. And all the automation that goes around continuous integration is kind of the things that I get involved with.
Right. Okay, so most people probably have heard about continuous integration. So why don't you give us a little bit of an, let's say, overview why this is important and what it is?
So continuous integration is all about ensuring that you've got better quality code. It's processes that have come about to help you improve the quality and the confidence that you have in the code that comes out at the end of the line. So the whole idea is that, 10, 15 years ago when people were developing code, particularly, big enterprise bits of code, what they would find is they would find that, as they're going through, you would have Bob developing on one side and he'd have his own branch and he'd be running and coding, and you'd have Fred running along doing some others. And once they'd completed their code, trying to get their code to work together in one program was a big problem. And also, once the code was finished, in inverted commas, there would often be lots of bugs, lots of problems, and lots of issues trying to get it into production. So continuous integrations is a set of practices that you can put into place to help you catch the bugs early, to help you get rid of this merge hell, and just also help teams be more efficient, to help them concentrating on getting code, getting functionality out there. Because it doesn't matter how beautiful your code is, it doesn't matter how wonderful the language is that you're developing in, particularly in the enterprise space. If it's not running in production somewhere and making someone money, it's absolutely useless.
Yeah, absolutely, yeah. The best you could say it's a kind of intermediate step towards that goal of running somewhere, but the agilists, of course, will say, no, everything needs to run every time, all the time. Anyway. So we covered the why. How do you do this? What's the let's say 10,000-foot overview over continuous integration?
So the key things key themes that kind of crop up in all these little practices that you can do is first around fast feedback. Letting the developer see very quickly if what he's doing is the correct thing and if it's working and if it's doing what he expects it to do in the context of the rest of the system. The other key thing that comes up is repeatability, being able to repeatably do it over and over again, repeatably test over and over again. That, again, what you think you're writing is actually what's supposed to be there. And the other thing that's kind of a nice side effect, which all us people who carry on about Agile go on about is it encourages collective code ownership. If you've got Bob working on a module over here and Fred working on a module over there, they become very possessive of their code, very protective of their code, and that's a real problem that causes lots of social problems within the development organization.
Yep.
And so by doing these practices, it encourages collective ownership. Instead of being proud and protective of your module, you can start being proud of the whole application that you're developing.
Yeah. So this is an interesting point because it probably requires that the organizational structure, the team structure, the project structure, the process takes this into account and is kind of adapted towards being able to have those properties you just talked about.
Yeah, that's correct.
So there's a process aspect in addition to a tool and practices aspect.
Yes, correct. It's not just, you can't just drop in some tools and it'll make everything better. You can't just drop in some practices and it'll make everything better. It's something that impacts the whole ecosystem of software development.
So let's look at some of the practices.
These core practices are the core practices that were outlined by Martin Fowler and Matt Femmel in their original paper on continuous integration. And they still apply today, very much so. Core practices being having a single source code repository, automating your build, automating your testing, and publishing the latest version of the distributable, the latest good build, so that people can actually get hold of it, the testers can get hold of it and play with it, and also so that you can actually get this build and put it into production.
Right. So let's look at each of those practices, I guess, and we'll start with a single source repository.
Yeah, so single source repository is all about having a single point of truth, a single place where you've got all the source code that makes up your application. 10 years ago, there wasn't much in the way of source code management tools and things like that. And I was working on projects when I was a developer 10 years ago. I was working on code on my machine, and my partner was working on code on his machine, and whenever we wanted to share code, we'd copy onto a disk and move it to the other machine. And that's very inefficient, and very soon you start to wonder which disk's got the latest version of the code. Where's that bug fix that I had? And it gets lost. And so it's all about having a central place. Nowadays, the source code management tools are more pervasive, and they're all over the place. People still, often in big companies that I go to and speak to, they still have this my machine mentality. All the developers are working in their own branch and working on their own code, and it's only every couple of weeks or every couple of months that they'll actually merge these branches together, and they'll have huge problems getting all this code working together. So one of the key things about having a single source repository is, these days, and we'll get into later in how language has changed, but these days it's not just having them in the same Subversion repository or the same Perforce repository or something like that, but actually all working on the same main line of the code, working together. So that there's a single source of truth where you get the code.
There's still a use for branching, but it's not per developer, it's rather per, let's say, customer-specific adaptation of the overall source tree or something.
Yes, correct. Branching is not totally evil. It still has its value, but just not having a branch per developer where each developer is by themselves writing their own code.
I guess it shows that I'm not that old yet, because I don't actually remember those days. I never came across this situation. Okay, before we move on to the next one, do you have any specific recommendations about which repositories are especially useful in a, let's say, agile environment and for this kind of approach?
Yeah, definitely. There's one thing, we'll get into tools a bit later, but the key thing about any of these tools is make sure you choose a tool that fits with your process.
Right. Okay, then let's cover that later. Okay.
Cool.
So next one is automate the build.
Yeah. So one of the key taglines that I really like is that using an IDE is not automating your build.
Why is that?
Because the whole thing about automation is you want it to be repeatable. You want to be able to get exactly the same thing at exactly the same time. When you've got lots of developers working on a team, working on a project, every developer has their own settings that they put in their IDE, their own little bits and pieces, and generally every IDE on every developer machine is different.
Yeah.
And so again, the key is about repeatability. If you've got a code drop in production, and 2 weeks after it's gone into production, you find a bug, you want to be able to go and see exactly how that source code was. But not only that, if you need to fix a bug, if you need to reproduce a bug, if you need to test that the bug has been fixed, you need to rebuild that code exactly as it was when you built it, however long before. And IDE settings change and stuff like that. So it's about getting, using one of the many build tools that are out there to create a system that'll automatically build it.
Yeah, yeah. And I guess one thing that's kind of interesting is that the configuration, or let's say programming of the build script, is something that is, by many developers it's seen as like the secondary kind of thing. It's just a build script. But I guess it's a good idea to at least conceptually look at the build script or the build infrastructure as yet another development, as a first-class citizen in the development environment.
Yes.
And, give it the necessary respect and treatment.
Definitely. That's probably my biggest battle that I have. And
I suspect.
It's something that I've been chatting here at Joe with Andy Glover about as well, because it's something that really needs to be sorted out in a lot of development teams. It's just, it's the ugly stepchild of software development. Yeah. It's part of your code. It's part of what makes your code valuable.
Yeah. And I guess the build automation, obviously, it doesn't just do the actual compilation. There's also about deployment units, packaging, testing, and that stuff.
Yes,
but I guess we'll look at that
exactly.
later.
Yeah, we'll get into that later. But it's all about making it all repeatable.
Yeah.
And also part of that is by having it on a build script and automating the build, it kind of helps to be able to reproduce the build.
Right.
And so it's no longer the case of, it works on my machine, why doesn't it work in the test environments? Why doesn't it work in every... By having it built on a separate environment as part of a continuous integration process, you're ensuring that, this, but it works on my machine, doesn't crop up and is not a valid excuse anymore.
Yeah, yeah. And there is the single truth, right?
So yes,
that's
correct.
Yeah. Automating testing is the next important ingredient, I guess.
Yep, that's right. And again, it's not just about automating your unit tests. Right. It's about automating all the testing around your software. Yep. So again, 8 years ago when the paper first came out, JUnit was new on the scene and everyone was getting their heads around this unit testing concept. And that's now a problem that's been pretty well solved, and there's lots of alternate tools and stuff like that. And so it's now expanding the horizon of where you get into the testing. It's moving into integration test, functional test, performance tests as part of your continuous integration process. UI testing, acceptance testing, a high level running right through your application. Yeah. And then also as part of automating the testing, making sure that you're actually asserting something in your tests, and then if something is wrong, you fail the build, and you stop and you let people have a look and get into it. Often I'll go to clients and they'll say, we're doing continuous integration, but we're not getting any value. And you have a look at what they're doing, and what they're doing is they may be running a nightly build, and 4 days out of 5, it's broken, and no one cares. And this is one of the key things when you automate your testing. Make sure that your testing is valid, and make sure that when the build breaks, when your tests fail, you fix them.
That's the highest priority. You don't do anything else until this happens.
That's one of the key things. When the build's broken, when it's red, get into fixing it.
The next one is about publishing the latest distributable, which is of course closely related to the whole agile idea, and making sure that every incremental release is actually useful to some extent to some of the stakeholders at least. So I guess that's what you're getting at here.
Yeah, exactly. It's one of the key things about when I talk about continuous integration and when I implement it at different clients, is that you only have one stage where you actually compile and assemble your distributable package, and that's right at the beginning. Your later automated tests further down the pipeline, they don't recompile their own version of the binaries. You have one place where it's compiled, and then everyone takes that distributable and they'll deploy it into a UAT environment. They'll deploy that binary into performance test environment.
UAT environment?
User acceptance testing. It's a common term in the UK. And then also, into your performance test environments, into your staging area, and also into production. That's the binary that goes there. Because this also makes sure that the actual distributable package that you're testing, that you're actually running all these tests on, is actually what's in production.
Yeah, and contains all the resources it actually needs.
Correct.
Yeah. Okay, that's well, if the first thing was the 10,000 foot overview, I guess now we're at like 3,000 feet. Yeah. And we can now look at the progress over time of some of the practices, tools, languages that are used here to make this a little bit more concrete and hands-on for people, instead of just talking about concepts.
Yeah. So this is practice evolution. Things that have come up that people need to do pretty much all the time that kind of help continuous integration be more valuable. The first one is really to commit more often. checking in once a week, is a bad thing. You need to check in at least once a day. These days, I try and get teams to aim for at least once an hour. Check in regularly, because what happens is if the build fails, and the build does fail, and that's not a bad thing. It's giving you information. It's more feedback for you to use. The key thing is that if the build does fail, then if you've your last check-in was an hour ago. At worst, you've lost an hour's work if you need to back it out or if you need to rethink about it.
Yep.
Whereas, if you're only checking in it once a week, you're going to lose a week's work potentially.
Yeah.
And it's about feedback. It's about context. It's about mental state. If you've just made a change now and something breaks, chances are it'll be very obvious to you why it broke.
Yeah, exactly.
And stuff like that. But of course, conversely, now this is where we start to get to the needs of the rest of the of the ecosystem, is that to do this efficiently, developers need to be given smaller units of work.
Right. But that goes together well with, the Agile XP, Scrum storyboarding kind of thing, where you write small, simple user stories and you break them down into steps that themselves, they might not have to make sense, but they're at least testable.
Yes, exactly. Small testable units, the whole test-driven development thing. Write your test, write your code. As soon as it's all good, check it in and go again.
Right.
And one of the key things also about committing more often is it forces you to update. If you want a clean commit, you need to be updating regularly.
Sure. But although this presupposes this kind of work with Subversion CVS, where you do a optimistic log merge kind of thing. I mean, in other environments, it might be different because you have logged all the stuff, so. Yes,
correct. Yeah. So generally I find that the pessimistic locking works, it has issues where...
Yeah, I agree. Just to set the context. Yeah. Okay, so next one is to make sure that every commit triggers a build.
Yes, that's correct. And again, it's all about fast feedback. It's all about getting those small changes and making less to fix and kind of getting that information going.
And do you really? Question: do you really want every commit to build, or is it good enough or as good to actually have a build every hour, so that effectively, more or less, every commit kind of results in a build? Or why is it important that the commit actually triggers the build as opposed to just having real-time building?
Again, it's all about fast feedback. You want to know why. If you've only got a build that's scheduled every hour, then basically, if you miss that hour window by 5 minutes, you're going to have to sit and wait and twiddle your thumbs and maybe work on something else. For 55 minutes while you're waiting for feedback coming back in. Whereas, I suppose it's a bit strange having a look at every commit builds, because there may be windows where a build actually runs 2 or 3 commits, and so it does get a bit strange. But
in other words, when the build is running as you commit, then you don't do anything.
Yeah, correct.
Wait until it's finished and then do it again.
Yeah, but then that runs the risk of if one of the previous commits breaks the build, you've now got more changes to figure out. It's not just one change set that's broken it. So ideally, you want every commit to build, and to do that, your build needs to be fast. You need to be able to get that quick feedback. If you're working on a 10-minute cycle, which some of the most productive teams I've seen, they're checking in every 10 minutes. Your build needs to give you your feedback within that 10-minute cycle.
Do you require or recommend that developers run their own build locally, and then only if that works, they check in and run the real build, or is that kind of overhead?
Yeah, no, I definitely believe that. I'm a big fan of developer discipline to get continuous integration working properly. One of the key things about it is developer discipline. The developers need to keep themselves disciplined to not check in on a broken build, to check in as frequently, to update frequently, to do this. And so there is probably a bit more discipline required on the developers, but part of that for me is developers running a local build. It doesn't have to be the full build, because that could take, they may have different spec machines, things like this, but just run a set of tests locally on the development machine before, once you've updated and kind of done a local merge, before you push that back, make sure that everything's working together, and then push it in, because you'll find issues probably, and that by fixing it locally, you don't impact other teams who've done that stuff and have already got it working locally.
The other thing then is to test in an environment that is realistic with regards to the environment the final product is going to run in, right?
Oh yes. Even up until recently, before multi-core processors became common, developers are generally working on single CPU desktops, and that's where they're doing the coding. And the biggest place we saw this was within multi-threaded code. Developers would run the tests locally on their single CPU machine, and everything would run fine.
Yeah.
As soon as they check it in, and the continuous integration server built it on a multiprocessor box and tested it with multiprocessors, they would then discover issues. They would discover race conditions and all sorts of issues. And again, it still applies today with things like cluster issues. If you deploying and testing, even in your continuous integration environment, if you're deploying and running your functional tests against a single node server and your production environment's a cluster, we've had issues where people don't discover these problems that crop up in clustered environments. And again, when you're testing in a production clone, it's not about this having the same scale, the same throughput, the same stuff, because generally at most you'll maybe have 2 or 3 users on the system. It's just about the architecture, getting the moving parts right.
Although it's probably worth mentioning that, of course, there are kinds of tests, let's say the classical unit tests, that don't necessarily require the full infrastructure to be there.
Yes.
Once you do integration tests with database access, with data replication, whatever, the thing we're talking about becomes more critical.
Yes, correct. And this is again where continuous integration pipelines come in, which is a whole other subject. But basically, it's all about moving it further on, testing, including with having the right database architecture. I've been on projects where, to keep the unit tests fast, they've been testing with an in-memory database. But the production has been one of the big relational databases. And then all of a sudden, there'll be small semantic changes in the SQL. There'll be bugs in either implementation that it works fine in memory and it runs fast. But trying to get it to run on the production database has been quite a lot of pain.
The reason why people ran it on in-memory databases is, of course, 2 things. First of all, the infrastructure might be expensive.
Yes.
And the other thing, if you run on a big system, it might take a lot of time to set the test environment up, and therefore it's a problem with getting the rapid feedback.
Yes.
So I guess one goal is to keep the build fast, and then how do you do this?
This is again where build pipelines come in.
What's a build pipeline?
So I'll probably touch on them briefly here. So this is originally a paper that Dan North, myself, and Jez Humble did at Agile 2006. And it's all about, instead of in the old traditional continuous integration concept, you would have a big build server. And, that build server would just, run something like cruise control. But then you'll just have a project, and that runs a build, and that's it, and that's all you have. What we found was when we were at clients, we needed more information. We needed the fast feedback from the unit tests. But we would have, functional tests, integration tests that were taking a long time. So what we'd do is we'd start to chain the builds together
in several stages or phases.
Stages, yes, exactly. So what you do is you have a pipeline. Going into one end of the pipeline is your source code, and coming out the other end is your production code. And what you do is the pipeline's made up of stages, and each stage consists of multiple jobs that can be run in parallel. So, your first stage, which is you're doing your building and your packaging, could also be running in parallel. It could be generating your Java docs. It could be running your code coverage or your static find bugs analysis or something like that. And, and that would all be part of the first stage. Running your unit tests. And then that would be the kind of key check-in mechanism. But then later on, further down the pipeline, once those had all passed, you'll then have another build that's now deploying it into a kind of small, fast environment, and then running a whole suite of functional tests. Does it all work? And once you've done that, and you're increasing your confidence as you move along. Okay, that works in that environment. Now we get to the resource-intensive stage. You may be, running with a big DB2 database on an AS400 or something like that. And then you run the same things again, but on the proper environment. And so it moves along further down the stages. And as you get further down, you get more and more confidence in the quality of your code, but you're getting the feedback earlier for your developers to allow them to track on. And the hardest thing about that from a developer perspective is actually having the discipline to treat just treat failures further down in later stages with as much importance as your early stage. That's
not
your
my
first
code.
feedback.
My code worked. See, that's the first stage. It didn't crash.
Yeah, but the key thing is to make sure that all the stages kind of are linked to one change set.
Right.
So that, if it does fail half an hour later in a production-like environment, you've got the change set, you can see what's changed it. And normally what that means is that you've then got a failure that you need to catch further up. And so what you'll probably do is you'll find, there's a unit test I can write for it that'll catch that environment, put it in, and then you'll catch it earlier.
Yeah, okay. So, and again, the reason for keeping the build fast, as you just alluded to, is to keep the feedback timely so you can relate to the source of the problem that created the failing test.
Yes, that's exactly it.
Yeah. Okay. One thing that I actually wrote down here as a note that I wanted to talk to you about, but now we do it anyway, is that of course you need a way to communicate failures and success and maybe also metrics, performance measurements back to the developers so they're actually aware of things.
Yes.
So what kind of tool support can you have to make people aware, to make them see what's actually happening?
So these are what I normally refer to as information radiators. Something that's just lying around, letting people know. Common things that I've seen is kind of lava lamps. Within the project area space, you'll have a red one and a green one. As long as the green lava lamp's going, it's fine. We've done it with lightsabers. We had the one client we were working at. We were in two buildings, but we happened to be on the same floor. It was a split team. We happened to be on the same floor on each of the two buildings, and we could see each other through the windows. And what we'd do is we'd have lightsabers in the windows, and then basically you'd just be able to look out the window and you could see what color the other team's lightsaber was, and you would know kind of where you were. So it's kind of getting this information. There's common tools like CC Tray and things like that, where you could just have it running on your desktop, and it'll just pop up little alerts when the build fails. There's big monitor screens that you can run. There's various little apps that tap into this kind of information, and just let everyone know this is the state of the build. Because one of the key things again is about developers, when they want to check in, they need to know, is the build green? Can I check in? If it's red, don't check in, because you're going to potentially make it worse. Make it worse. Yeah, exactly. And also, if you notice it's being read for a long time, someone's having a hard problem, you can then go in there, see what the change set is, see who last checked in to make the problem, and for the tech leads on the projects and stuff like that, there may be a chance for them to walk over to that developer and say, hey, do you need help with this problem? And again, this is the collective ownership coming in. Everyone being concerned. Exactly. And again, it's not about blame. It's not about you broke the build for the 10th time today. It's that could be a further indication of something else that needs to happen to bring it up. Yeah.
And in addition to the big red-green lamp, I guess, you might have some kind of web page that gives you an overview of the failed tests and some statistics about, whatever.
Yeah. So there's been a lot of movement lately in the continuous integration server space. ThoughtWorks wrote the first continuous integration server, Cruise Control, which kind of came out at the same time. This was the Spike project that Martin Fowler and Matt Femmel were working on, that they actually first wrote the paper on, was the core code for Cruise Control came out of there. But these days, even at ThoughtWorks, we've realized, hey, Cruise Control came to a certain point, but we've now got our own CI commercial rewrite from scratch CI server product out there, and there's loads from different companies. There's commercial ones, there's open source ones, and they're all really good, and they're all homing in on this concept of getting this information feedback. There's some of them do really good graphs. They'll start to trend stuff over different builds. You'll start tracking things like code coverage, performance test results, all this kind of stuff, number of unit tests, build times and stuff like that. And so you can start getting more information. And so what you can do is you can start actually setting kind of more soft failure conditions. One of the projects I did a couple of years ago, which is one of the first ones I got involved with doing this, was running performance tests. Now, performance tests are kind of probably the only case where I'd say, schedule them to run overnight. Just pick the latest green build for the day and run them overnight. But what we were doing is we were actually every night we were setting, what the current latency was, what the throughput was, stuff like this. And what we would do is we would check and we'd set a deviation. If it's now more than 10% slower than it was last night.
Trend analysis,
exactly,
right?
Trend analysis. if the trends are starting to go the wrong way, break the build, fail the build, because it's only about a day's work that introduced something that's, has a huge impact on performance.
Yeah, I know the Eclipse guys are also doing this. And that's very, very, because it's a way to make performance degradation measurable as a criterion for failing the build. Yeah, that's very useful. Automating deployment is, of course, the last step in a build pipeline. It's not the last step, it's the last step. You do the automated deployment and then you run the final tests. Any thoughts about that?
Oh yes. So this is one of my my big ones that I really like, that I've been pushing hard for, and it's become quite accepted recently. Is the whole concept of the way I describe this is one of the very first clients I was at ThoughtWorks. We got there. The go live was a big deal. What would happen is they would start, 6 o'clock on Saturday morning, really, really early, and they would shut down their entire system. And what they would do is they would work through, and hopefully by Sunday lunchtime, they would be able to bring the system back up again with the new release of the code. And there was huge amounts of stress, huge amounts of panic, huge amounts of management visibility, paying close attention to what's going on, because they had this huge manual process of actually getting the code into place. 3 months later, we worked very closely with the ops team. We brought them in, we sat down with them, and we helped them kind of write a deployment script that would actually take the code from the CI server and actually push it into production. And what we did, we started further upline. We started pushing into the staging and the testing environments and stuff like this. And what happened is, within 3 months, what we were doing is they were doing go lives on Friday lunchtime with less than a second downtime. And they were doing it while users were on the system. They would, drop a new deployment and go. So, by automating your deployment and by making your automated deployment part of your continuous integration ecosystem, is when you're doing your functional test, not only are you testing your application, but you're testing the mechanism that puts your application into production. And by getting your operating system, your ops guys, involved in the process early, they get confidence in it as well. So it's not only you getting, and your project managers getting confidence in the quality of your code, it's now confidence from the operation guys that they're not going to get called at 2 o'clock in the morning because something's exploded. Confidence in the actual deployment mechanism, so that they quite happily just run the script, whoosh, there it goes, no more problems.
Yeah, that's a very good recommendation to, always to get the ops team involved early are probably very good recommendations, because usually they kind of scream at the end.
Yeah, exactly.
You didn't tell us this. Okay, language evolution. Remember, we were talking about evolution. We talked about practice evolution, and now we look at language evolution.
Yep.
So, build.
Yeah, so 10 years ago you talked about a build. What you're talking about was, probably at best, compiling and linking your code. Hooray, my code compiles, it links with all the libraries. That's it. Nowadays, generally, when we refer to a build, we're not just talking about those two stages, but we're also talking about, running unit tests, running code analysis, creating the final deployment package, and even running the deployment. Invoking the deployment scripts from your build script. And this is one thing where some people get confused, is, you have these build scripting languages like Ant. One of the I deal a lot with Ant, and I quite like Ant. But, I often see developers who try to take this a bit too far, and they actually try and write their deployment mechanism in Ant. Ant's a language for doing building scripts, for compiling things, for managing dependencies and stuff like that. It's not particularly wonderful at doing deployment, but, write your deployment script in something that makes sense, and then just use Ant to invoke the deployment script and use it, because the operating system guys, the ops guys, when they're doing the deployment into production, they don't want to be running Ant. They want a shell script. So if you're just invoking a shell script from your Ant, everyone's covered. Everyone's happy.
Okay. Integration?
Yeah. So, again, years ago, integration used to mean getting code from various team members working together, getting their code integrated together into one product. Nowadays, I'm often hearing the word integrate, meaning getting various projects working together, getting various modules working together, and also getting our systems working with our third-party vendor systems.
That's upstream. A pain sometimes.
Yeah. And then again, testing. Testing's also evolved. It used to mean, maybe testing my code in isolation before I checked it in. or just testing that it compiles. And generally, you would find an attitude of, okay, take this test code, take the code, it's compiled, it linked. Now it's up to the testers to test it, and it's kind of bringing this responsibility back home.
Avoiding the throwing over the wall problem.
Exactly. It's all about teamwork, and it's again, testing is not just unit testing. It's also various levels of acceptance testing, integration testing, performance testing. There's loads of different tests that you now need to run.
Yeah. I guess build and integration and continuous integration is one of these things that obviously rely heavily on tools.
Yes.
So I guess we should take a look at how the tool landscape evolved over time and what today's state of the art is, I guess. So for source control versioning, what's the state of the art there?
Yeah, so source control systems, they again, even as recently as 4 years ago, loads of companies, I suppose even nowadays, are still using CVS.
Yeah, sure.
And the thing is, CVS all being file-based and stuff like that, if you're running your Cruise continuous integration server, that's polling the SCM looking for changes. CVS dies. CVS can't handle that.
Yeah.
Whereas the modern source control systems, can all cope with this load. They're much easier at handling polling, has something changed, getting this information out. Yeah. And so these days, all the good ones they can cope with the load of being polled and look for changes by CI servers.
So what do you mean by today's system? Obviously, there is CVS's successor, Subversion.
Yeah, so Subversion's great at this, but also, we're starting to use a lot of Mercurial internally at ThoughtWorks, especially with our distributed Agile, with our distributed teams. Mercurial is wonderful for that kind of stuff. There's some teams on some projects using Git. Particularly for the Ruby projects, they seem to tend to like Git. And all these tools kind of handle it, but also some of the commercial ones that we're using in our clients. Perforce handles it very nicely. And so it's states like that. Those are the players that I think are handling it very nicely.
So what is different in tools like Mercurial, and maybe we should do an episode on that at some point and looking at those different systems. Can you give us a brief overview of what those systems, how are they different from what Subversion does? I mean, why are they better, maybe, or aren't they?
It's all about how you use it. I'm a very big fan of choosing the right tool for the right job. And yeah, you're right. Distributed source control management systems, that's an episode all in itself. There's lots of lovely things you can do with it. But I mean, what the key difference is with something like CVS, with Subversion, what you have is you'll have a central source code server, and everyone checks in and pulls out from that, and that's the central source of truth. Whereas with the distributed ones, you've got an entire repository copy sitting locally on your machine. And then what you're doing is, you do local check-ins, and as you work, and then what you do is, the way we work with Mercurials, we'll have a central Mercurial server, which is our central source of truth. No matter what you're using, you need to have a central one that's the boss.
Sure, yeah.
And then what happens is we'll be developing locally, making little commits locally, and then when we're happy for the CI server to pick up our changes, or when we're happy for the rest of the team to pick up our changes, we push it.
Kind of a two-stage commit in some sense.
Exactly. And that's great for spiking and stuff like that. Yes. You can spike it out in a little branch, and it doesn't work, or stuff like that. And so that kind of really makes a difference. But what we have is Cruise, our new CI server. I'm part of the development team, but the development team split. There's guys in Beijing, there are some guys in Bangalore, there's me in London, there's some guys in San Francisco, and so kind of particularly in some of the lesser developed countries, bandwidth is a problem. There's not enough bandwidth, the line goes down, stuff like that, and so just being able to do the commits locally, to do the tests locally and stuff like that, and then when the link comes up, hey, there we go.
Okay, the other thing is then, of course, all the kind of static analysis tools you can run as part of your build to give you more information about your code quality. That's something that has received quite a bit of attention over the last couple of years, right?
Yeah. This is probably the next area which is going to see loads more tools coming in, and which is really great. I mean, there's your test code coverage, and we're even getting project managers and program managers come to us, and say, I've got 40 projects under my control. I want to know how well they're doing, and one of the key metrics that they're asking us for is I want to see what the code coverage is across all the team, all the programs, and stuff like this. Bugs, bug analysis, find bugs is one of my favorites for Java because it can pick up all these weird and wonderful little issues that we get. And again, style, if you want to encourage developers to work together, you need to kind of have some agreement within the team on style and how you're going to do it. And so things like check style and all the rest are great for enforcing, common readability rules throughout your team. Again, looking at cyclomatic complexity, failing the build if you get code that's too complex coming in. Failing the build if your code coverage drops below a certain percent, and stuff like this. And then also visualization, being able to visualize, what the trends are in my code. Where's it going? Where's my performance going? Where's my, coverage going? Be able to see all this. And this is, all the metric stuff. Tracking, some of the issues around, performance, code coverage, build times. Build times is a key one that people like to start track. Has my build suddenly gotten slower? Especially in functional tests that are starting to interact with the database. If your build slows down all of a sudden and you haven't really made that many changes to your tests, chances are that's an early stage performance test, flag that'll pop up and say, hey, there's something wrong in the performance of your code.
Okay, let's look at testing tools. I guess everybody knows JUnit or whatever unit, NUnit, CUnit, SUnit, whatever, RUnit. Any other things worth mentioning? And we'll certainly have an episode on test-driven development and testing tools at some point. But quick overview.
Yeah, so testing, the unit testing tools are now pretty well understood and covered and stuff like that. But there's something that people are starting to talk about a lot, which is there's a whole group of them collected together. Martin Fowler calls them test doubles. I'm not sure if he coined the term or not, but on his Blicky he's got a page about them. And that covers things like, stubs and mocking, where you kind of pretending to get information back, or you want to have a look at the flow within one of your classes within your objects, seeing how they're actually working. And again, things like behavior-driven development, getting all this kind of information in, running different types of kind of business-driven functional tests, fit tests, Selenium tests, driving the web browsers. Piao Zhao, on Monday, we launched a new product, kind of the first beta of a product of ours called Twist, which is again about having a whole IDE for managing your tests, but having it in such a way that even the management people who kind of know what they want the system can do can go in there and kind of describe at a high level what they want their code to do, what they want the application to do. So there's lots of kind of testing tools coming up here, and there's lots of interesting work going on in this area. So again, this is probably one of the other ones that's kind of been there from the beginning, but it's still got loads to give, loads of value.
It's interesting to see that it's fair to say that if we want to increase or improve the state of the practice in software development, we should focus more on those, not on inventing yet another programming language, but rather on some of the, in some sense, peripheral issues like build, test, integration of domain experts and stuff.
Yeah, exactly. It's it doesn't matter how wonderful your code is, how clean and complete and stuff your language is, but if you can't test it, if you can't repeatably make sure that it's doing what it needs to do for a business to make money, it's it's really an academic exercise more than anything else.
Yeah. Finally, I guess there is the tools that pack all of the stuff we talked about together, the CI servers. And of course, CI doesn't mean corporate identity, but rather continuous integration.
Yep. Yeah, and again, this is somewhere where I've been quite personally involved in the past year or two, is in watching how these CI servers have taken off. It used to be, there was just cruise control, and then Antil came along, and then, then there was some, bit of Continuum and all the rest and all of these others. And then all of a sudden in the past 2 years, there's been this explosion. There's, loads of different vendors out there. There's Bamboo, there's TeamCity, there's, Hudson, there's commercial ones, there's open source ones, and they're all trying different areas. You can see, different people's approach to continuous integration and what they want to get out of continuous integration. And it's great seeing this. One of the key trends that are emerging out of this is, in the old days, you used to have a build server, and it was a big build server, and it used to be a very expensive machine. And after a couple of years, this thing would have issues coping with all your your projects, and you'd have real trouble getting management buy-in to kind of upgrade the server because it used to be a really heavy spec machine.
Yep.
Nowadays, pretty much all the leading contenders in the CI server space all have this concept of agents, and so you now have not just one big server, but you have a build grid, so they'll farm out the jobs to whatever machines out there.
Yep.
When I was, showing our product to one of the big media companies in the UK, the guy I was showing it to turned back and said, "Wow, we now finally have a use for all these overpowered machines we're putting on management desktops. They could make them agents in the background to be running builds, to be running unit tests, to be running the code analysis.
Built at home, right?
Yeah, exactly. Having these big grids, and it's wonderful. It's great use of resources, and stuff like this, and also kind of helps, particularly for product companies. It helps testing on multiple platforms because now what you can do is you can have a stage that's running tests on OS X, on Linux, on Windows, and various flavors of all of them. And as long as all the jobs running in parallel, as long as they all pass, then the stage is complete. You've got exactly the same build that's passed on all the platforms. And so it's pulling all this. A lot of them are starting to put in personal builds. I personally, I'm not a huge fan of personal builds. I can see where they have some value, but personally, I think there's more value in kind of developer discipline in running local tests before they check in. But the whole concept is, instead of running your local test on your local machine to see, am I safe to check my code in, what you do is you then basically say run a personal build on the grid, and what it'll do is it'll take a diff of what's currently not checked in on your machine, submit it to the CI grid, and it'll run in the full CI environment, and then give you a yes or no, and then you can say, all right, okay, it passed, I'll check in, or no, it's failed. So on the flip side, it does have benefits. It means, if your build is a bit longer than the normal check-in cycle, you're still testing in the right environment before you check in, and so kind of keeping less impact on the rest of your team when you make changes and stuff like this. So that's pretty common these days. Pipelines, there's one or two, us in our cruise product, we're the only ones that really call it pipelines. But there's similar things in some of the other products. They're following. They don't use the same names. I can't remember the names they use, but Pulse does something similar. Antil Pro does something similar, and it's great. Actually, I'm going straight from JAO to KitCon, the Continuous Integration Testing Conference as well, where this is a time where all us guys kind of work on these various products, get to sit together and get to talk about our different products, and it's great because it's really driving out this competition, and we can start to see how other people are thinking and approaching this whole continuous integration problem.
I guess the next level of granularity in tools above the continuous integration server is then stuff like, for example, JAS, which integrates version control, reporting, team collaboration, change sets, environment replication and stuff with testing, building, deploying. So this is this whole team enabling tooling kind of.
The whole application lifecycle management is lifecycle management thing, which I've heard it called. It's exactly bringing all these bits and pieces in together and kind of bringing it all into one space where you can kind of get a general feel for how everything's going.
And express relationships between things so that you know that a certain commit of a certain change set resulted in this and that subsequent problem. Because if you don't know that, it's obviously hard to trace things.
Yes, exactly. And also tracing further back up the tree, seeing which stories, which business requirements actually drove those changes in the first place.
Okay, this brings us to the end. Anything else? Any pearls of wisdom, as the space show guy likes to say, that you want to leave with our listeners?
Probably the biggest thing, which I tell to all the clients where I go and try and implement this, or where they come to us and they say, can I have a CI health check? Can I see what we're doing? Is kind of be pragmatic about it. As in all things, these are guidelines, these are principles. You've got to choose the tools that fit most with your way of working and kind of fit with the benefits that you want and the pains that you're having, and kind of it's not a silver bullet. I've been doing this for quite a number of years now, and it's not a silver bullet. As we said in the beginning, it's not something that's totally isolated to the developers. It's got to expand your whole development organization, from the management all the way down to the ops guys looking after the production systems. Unless everyone's kind of doing their part and pulling their weight, it's really going to be hard to put in and hard to implement and hard to look after and hard to see the value.
Yeah, and I guess that's important. If you don't see the value, people won't be willing to do it.
Exactly, because it can be a painful process.
Okay, then Chris, thank you very much for being on the show.
Great, thanks for having me.
Absolutely. Thanks for downloading and listening to Software Engineering Radio. Software Engineering Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example by clicking on the Dig, Reddit, Delicious and Slashdot buttons. To contact the team, please send email to team@se-radio.net, or if it is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under a Creative Commons 2.5 license. Please see the website for details. Thanks to Charlie Crow and the PodSafe Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.